It'll actually be recording. Okay. One of the things that I mentioned that we would do would be to go through the various sets of assignments that I had you do over the last couple of weeks. I put up an answer sheet, but then I realized it was incorrect and was the wrong answer sheet. So I corrected it as of about an hour ago, and maybe even more recent than that. I don't know. I don't know where the one that I put up came from because it was way off base, and so I had to go back through and put another one up. But the one that's up there now, I believe is correct. And so that'll be the one that we'll kind of work off of to kind of work through the answer sheet. And we'll add a few little wrinkles as we go along too, just some additional explanation of some things that we'll kind of encounter within the data, the actual outcome tables that may or may not be useful if you decide that you need to interpret just a bit more. And so we'll kind of handle it that way. I'm going to pull up the, where am I? I'm going to pull up the overhead projector piece that I have and see if we can work off of that. I find that a little bit easier to use than to work off of a PDF on the right off of the As You Learn page. And so what we have here is what we have here is simply the answer sheets for the 6 different little examples and answer sheets and questions that I actually ask you to deal with. And we're working off of a data set that we'll use kind of going forward for a couple of sessions, and we'll use something very similar, a different sort of cut from the data set as for the final evaluation piece when we get to that piece. So I wanted you to be kind of engaged with the data set that's built around public health. And this particular data set is one that comes about as a result of a survey that's done annually by the National Institute of Health. And so it's a survey that collects data from around the country and in sort of random sampling through different health agencies. And it's, the feds, since they provide federal funding, they can also, put some pressure on agencies to be able to, get people to respond to their surveys. And very similar to what they do in education, there's a regular survey that's done every year in education from various sites around the country. And this one is just health related and public health related. Several years old, but, they don't give you the most recent ones. And it had to do with some habits and some life habits and some, related to smoking and related to other things that people might be engaged in. And so one of the questions was a descriptive question, and it had to ask you to pull up some descriptive statistics from about the age at which people actually began smoking, and whether those, whether that distribution was in any way compromised, or whether it was a distribution, and talk about some of the qualities of the distribution. And so in the question set, one of the things that was drawn up was ask you to identify the mean and the median. And once again, those are things that we would use to sort of describe the nature of the distribution and how normal the distribution might be in this particular data set. And within that, and we'll come back to the standard deviation in a minute, but within those two values, The mean for the age at which people began smoking cigarettes full-time or regularly was 18.03 in this particular data set, and the median was 17. Now, what that means, and this is one of the errors that was in the previous answer sheet, what that means is that the bias, because the mean is higher than the median, that the bias is in the direction of the mean, and since the mean is higher, it's in what we would call a positive direction, or to the right. Now, what that essentially means is that there are outlying scores to the right in this thing, which is age related, that would be, which you would, if you think about, you know, the nature of the age at which people began smoking, if 18 is the median, half above, or 17 is the median, half above, half below, well, the half below can only be so far below because the age is 17, and the half above can be way above. Literally, in this case, there are some, it looks like there's some actual cases of people that didn't begin smoking regular until their 40s and 50s. And so what it typically means when the mean is higher than the median is that there are outlying cases, or cases that are significantly above the mean in one direction as opposed to the other. In this case, the outlying cases are to the right, or positive, as we would call it. Yeah. We ask about what would be scores that would indicate a significant difference between the low score and the high score. In other words, or what would be the age at which, either younger or older, we would say this person was significantly younger than the group or significantly older than the group when they began smoking. And for that, we needed the mean plus the standard deviation. And so the standard deviation in this case was 4.753. And understanding that how we define significance in a distribution of scores like this is, what's above what's beyond the range of the middle 95%. And the middle 95% is defined by 2 standard deviations below and 2 standard deviations above the mean. So in this case, the calculation gives us that anything that's less than 8.54 below the mean, in other words, if somebody started smoking at 8 years old, that would be a significant difference from the group, and a significant concern too, but certainly a significant difference. And if anybody was older than 27 and a half when they started smoking, they would be significantly older than the group. But that was defined by, 2 standard deviations above the mean, or 2 standard deviations below the mean. And that defines the middle 95%, or defines the boundaries at which anything below or above is considered to be significant. Now, I also asked for the range of the scores, and that's pulled from the minimums and maximums. The minimum value is 2, and the maximum value is 50. So the range is just the difference between those, and so the range is 48. Okay. All right. The second question dealt with independent samples t-test, and it looked at once again the age at which people began smoking, but if there were differences between gender. Now, we didn't necessarily identify groups 1 and 2 as to which groups those were. You'd have to go back and look at the, I believe it was gender. Wasn't it gender? I don't have the answer sheet in front of me, but I think it was. They defined the 2 groups, and we want to know if there is a significant difference between when the 2 genders began smoking. And when we ran the independent samples t-test, which we ran because it was 2 groups, the p-value was greater than 0.05, and so it's not significant, and so that's the end of the question. We don't need to talk about the differences between groups. We don't need to worry about the differences between groups in terms of absolute value. We just need to know that the difference is not significant, and so it's kind of meaningless to think about it. And so the answer to the question is, since this is greater than 0.05, p is greater than 0.05, it's not significant. And that's the end, that's really the end of all statistical questions. If we discover that it's a non-significant outcome, that's the end of it. We don't bother to try to figure out anything else because it doesn't mean anything. The third question, which was once again one of the errors on the previous answer sheet I had up, ask if there was a significant difference between the age at which people tried smoking and the age at which they actually began smoking regularly. Now, even though those are 2 different variables, we can look at variables like that because we want to know, is there a significant difference there? Or did they relatively start smoking pretty soon after they tried? And so since it's 2 measures on each individual, pre and post, it's a paired t-test. And so the paired t-test, when we ran the age at which people tried smoking against the age at which they actually began smoking, regularly, we discovered that there's a p of less than 0.001, so it is significant. And that when we look at the descriptive statistics, we find that people tried smoking at roughly about 15 and on average did not actually begin to smoke regularly until about 18. And so there was a significant period of time between when they tried and when they actually began smoking. Now, as a public health person, that might be an interesting piece of information because it means that we have the opportunity to intervene. We have the opportunity sometime between 15 and 18 to try to intervene with students to figure out, okay, can we do something here that will, help people not begin, not go to regular full-time smoking. And so even though it's a question with 2 slightly different variables, it might provide a meaningless sort of, or excuse me, not meaningless, but it might provide a meaningful amount of data or meaningful analysis because it would, let us think that, okay, well, we have some time there. Maybe we can do in those 2 or 3 years, maybe we can put a program in high school or something like that to attempt to deter people from becoming full-time smokers. Yeah. The 4th item was comparing what age people tried smoking in this group. Is it different from a national sample or a national average of 13 and a half? And the year this data was collected, that was the national average at which people tried smoking was 13 and a half. And so we wanted to know, is this is this group, this sample that we pulled from the survey, is this different from that national average? And so the measure is to find out if there's a difference between the mean of 15.3 and the national average of 13.5. And the answer is yes, there is. The significance is less than 0.001. And this group tried smoking later than the national average. So once again, we begin to think about, okay, why is that the case? Why did this group start smoking later than the national average? And it begins to, bring to mind, okay, is there something different about this sampling of this survey that would make it different from what we think the national average to be? Or, is this just a unique group within this survey that just started smoking a little bit later? And so it raises the question of whether this survey is, generalizable to the larger population, because this difference would be something we'd want to figure out. Why it's different? Because we would expect it not to be necessarily, if it truly is sort of a random survey. And that's the one sample t-test. Okay. The fifth one dealt with more than two groups. And we were looking to see at what age did people begin smoking regularly. And the variable that we were wanting to compare between was a variable called the type of county. And the type of county had three levels. One was urban, suburban, and rural. And since there were three groups, we couldn't use t-test. We had to use analysis of variance. And it's an F statistic. And so we found the p-value to be 0.004, which means it's less than 0.05. So there are significant differences between these types of areas, at least in this sample. And what we have to do when we do one-way ANOVAs like that is we have to do what are called post hoc tests to see between which groups. And so when we get into looking, between which groups, we see that there are significant differences between group 1 and 2, and there are significant differences between 1 and 3, but not between 2 and 3. So when you think about it, you've got 1 up here, and then you've got 2 and 3 pretty close together. And so there would be differences between 1 and 2, differences between 1 and 3, but nothing going on here between 2 and 3. Now, when we know from the coding that the coding is metro, non-metro, and rural, or metro, small metro, and rural. Small metro is basically suburban. And so we can come to the conclusion, looking at the ends, looking at the mean differences, this would tell us that the urban folks began smoking later than the county folks, because the way this mean difference is calculated is on top of the test, on top, it's one group minus another group's mean, and then it's one group minus the third group mean. And then the third option is group 2's mean minus group 3's mean. And so the fact that this is positive, the fact that this particular outcome here, the 0.879 is positive, would tell us that this has to be greater than this. Group 1's average has to be greater than group 2's average, which is age. And so group 1 started smoking at an older age than group 2, started smoking at an older age than group 3, and group 2 and 3 started smoking at about the same time. So urban people started smoking later than suburban people, and urban people started smoking later than rural people. But suburban and rural people started smoking relatively the same time. Does that make sense? Do you see the logic there? Okay, so you have to know the coding. You have to know what the coding is on the variable, but at the same time, you have to also understand that in these post hoc tests, the way they're calculated is one mean minus the other. And so whatever order they are up on the screen, up on the sheet, then that's the order that you have to follow and overlay the coding scheme on top of it. Okay. Then the number 6, or the final question, had to do was a regression. And because you were asked to make predictions, you were asked to, we're going to predict, silly thing. Stay. Okay. One score from another. And the prediction we wanted to know was, does weight predict body mass index? Does weight predict body mass index? And so we first, the model, we don't really need to worry too much about what's going on in here. But we do need to understand, is it significant? And it is significant. P-value is significant. So we know it's a significant model. The coefficients for the intercept is 5.75. For the slope of the x variable is 0.123. And so we always know that, we're predicting, in this case, BMI from weight. And we plug in the coefficients, we plug in the unstandardized coefficients, and we get this formula. BMI is equal to 0.123 times pounds plus 5.75. And we have to, when we go back up here and look at these coefficients, we have to honor any signs that are here. Any positives or negatives. In this case, they're both positive. And so we end up with, positive values in the equation. And if you plug in 200 pounds, you would get a BMI of 30.35. So we would classify this person as obese. And if they could lose 10 more pounds, we would just classify them as overweight because they would get below 30 probably. I know that because I lost 40 pounds in the last year and a half, and I went from technically obese to now I'm only moderately overweight. So I like, categories are important to understand, what they mean to people. And so we can predict BMI from weight, what we'd expect to see. Any questions about those answers? Okay. Gosh, I don't know what that was. Something. Let me stop this share. Okay, I'm going to stop this recording here because I want the answer stuff to be separate from the discussion stuff.